So we are starting the next session now. Go for Pythonista. I'd like to present the speaker. He's Yoshifumi Yamaguchi, and he is the developer of Python and Go, and also infrastructure. And he has a 5 years of experience. He develops command line tools, mock applications, do data analysis. And he's also the co-organizer of Go user groups in Tokyo. Please welcome our presenter now.
Thank you for introduction. Hi. Today I'm going to talk about Go for Pythonistas, as you can hear. First of all, I have to give you a caution that this presentation is mainly about Go, not the Python, though this is the PyCon, but it would be great if the Pythonistas like you guys can have Go as a second mother language, because Go and Python is really similar each other, but Go does have some the lacking feature of the Python lacking features. So if you can choose the Go as a second mother tongue, maybe it'd be great. So who am I? My name is Yoshifumi Yamaguchi. I work for YouTube technical manager at Google, doing like sales engineer like job. And then I have the introduction says I am an enthusiastic Pythonist for over 5 years, and then at the same time now I'm a fanatic golfer. So that is the reason why I'm giving a Go presentation here. So I have a question. Question. This is my experience. The languages I have used so far was C++ for some doing large computation, and then Java and PHP and OCaml. And then mainly I have been using Python for everything, like creating tools or web applications, and at the same time Go for everything. So, and then which languages do you use? Since this is the PyCon, so most of you guys are using Python, but other than that, maybe you're using C or Java or JavaScript, some kind of things. But I have a question. Why are you using these languages? Maybe the reason can be like this. Execution speed is fast, and no need to build, and or no need to write annoying type definitions, or easy to test, and then blah blah blah. But at the same time, maybe you have some complaints on these languages. Maybe the reason going to be vice versa. So execution speed is slow, or too long build time. Some dependency notation such as writing make files or Maven. So in the case of Java, maybe writing the Maven setup files, so you can sometimes you're confused that you are writing Java or XML or something. And then also how to develop right after the fresh install. So in the case of Perl, you have to install lots of stuff from cpan or something. So maybe everyone has a similar issue. So this is the important point for introducing Go, because the history of Go started from this kind of complaints. One day, Lou Pike, the father of Go, thought that the contemporary language should have it should have this kind of features. The Go is mainly developed by the Googlers, and then Google has lots of libraries such as for Java or C++, but it depends on the lots of libraries, and it takes a long time to build. So they wanted to make builds faster, and at the same time, they do not want to write really long dependency configurations. So they wanted to have such kind of system to solve the dependency more easier. And also they do not want to test for type checking types. So they wanted to have strong type, and then at the same time, the flexible and then quick type checking type system. And also manually maintaining the memories is really tiresome, so they want to have garbage collections. Then at the same time, the contemporary CPUs have lots of cores, maybe over 6 in the case. So multi-core support is preferable. And then the last thing is the easy to write grammar is important to faster development. So these 5s are the important feature for contemporary languages. So they started creating the Go languages. The project started from 2007, and then it was released in 2009 as a version 0.4. And then last year, we released version 1.0, and then this year, in May, the version 1.1 was released. And then from 1.0, the runtime system was really improved, so now it runs much faster. So the Go is gradually getting ready for production use for all programmers. So today's agenda. So today I'm going to introduce these topics. And first of all, I'm going to introduce a runtime and a build time environment for Go. And after that, the language specification and the standard packages and the tools. And then this is out-of-the-box features, but I'd like to introduce more external services with Go, such as web application platform, and also the actual practical use cases. And then for the people who are interested in the Go, and then to start studying Go after this session, I'd like to introduce some pointers for information of learning Go. Okay, let's start. Runtime and build. The topics here is mainly focusing on execution speed and build easiness and then supported platform. So premises, Go is a compiled language, so we need to build the program before running it. And then compiled binary is platform native, so different from Java. It doesn't create a class library, but it creates a native one single binary. And then runtime is included in the binary build, so you don't have to have different from Java, so you don't have to have independent runtime system. And then expectation is that the Go is a compiled language, so a bit slower than C, but much faster than lightweight languages. Then this is a benchmark from a computer language benchmark game. And then as expectation, the Go here, compared with the GCC, Go is the 3 times slower than C, but almost competitive with Java. And then Python 3 is here. It's like as expected. Then the comparison table of each benchmark. Then the latest version 1.1.2 is like this. So compared with C, the speed is almost same Java. So it seems like productive for speed required use cases. And then about the build easiness. In Python, the no compilation is required because it's a scripting language. And then package management tool solves the package installation, so such as easy install pip. And then in the case of Go tools does that kind of stuff. So Go tool automatically solves the dependency and build. For example, there is a source code like this, and then if you need some external packages, you can specify the path to repository directory like this. So if you need some third-party library stored and put in GitHub or Bitbucket, you can write like this. And then if you type go get, then go tools fetches all the required packages from each repositories and stores in the specific directory. And then after that, you can hit the go build command to build a binary. Then in this case, the binary main is built, and then you can execute the main command like this. And then the supported platform. In Python, the most platforms are supported like Linux, Mac OS, BSD, Unix, and Windows. And then it's same as Go. The Go supports the combination of this computer architecture and OS. So the interesting thing is that if you want to create the binary for Windows, you can build the binary for it from on the other platform. Say if you are using the Mac OS, but you want to build something for Windows, then you can create a binary for Windows on Mac OS using a cross compiler of Go. But this is not the optional. This is not the external feature, but the out of the box feature. So this is really interesting for it's an interesting feature, I think. Then going to next topic. Topic here is the language specification. Go has a strong typed but a flexible type system, and also the interesting thing is Go is that since it is created in 2007, it means that Intel already released multi-core CPU. So the language specification itself includes the support for concurrency. So this feature is called Go routine and channel. So in the case of Python, the Python is a dynamic type system, and it is allowed to reassign the different type value to one variable. So for example, like as in right box here. So for example, you assign the int value into the variable A, but you can assign the strong type value after that. It is allowed to do. And also, since the Python is an object-oriented language, so the class and the method is supported. And in the case of Go, since it is a strong typed language, so this is not allowed because the C is the type of Celsius, but F is the type of Fahrenheit, so it is not allowed to calculate the different type each other. So if you want to do that like this, if you want to do that, you have to cast the value explicitly like this. So, and in this case, both of them are Fahrenheit type, so you can calculate each other. Since this kind of feature is implemented, the all type checks are assured after the compilation. So this is really helpful for us because in the case of Python, we have to check the type check type in test, like unit test. But in the case of Go, we don't have to do that because the compilation checks all the types. So. But at the same time, Go has a type inference system. So this is a redundant way to write to initialize a variable in Go. But you can write like this. For example, C1 is inferred as a Celsius type because the right-hand side is a Celsius type, so C1 is inferred as a Celsius type. then she is ensured to be associated because C1 and C2 is associative type. So in this kind of process, Go can infer all the types in some program. And also, speaking of classes, the Go doesn't have class, but instead of class, they have the struct. So struct can have fields like this. So in the case of this, the rectangle struct has a width and length. Both of them are int type. And also, the structs can have methods. So if you want to calculate the area of a specific implementation of rectangle, you can call the methods for it. And also, other than the struct, Go has an interface type. The interface makes it possible to do some duck typing like program. For example, the type shape interface defines area method. The area method has to return the int type value, and rectangle, the struct implements the area method. But if the one struct implements a method defined in an interface, then Go recognizes that struct as the implementation of interface. So in this case, the rectangle is recognized as the implementation of shape interface. So you don't have to write this kind of stuff. For example, the uppercase is the Java, and the lowercase is in the case of Python. You don't have to like this. Just implement the method for interface. And then area is implementing the shape interface. So you can cast like as an interface as well. About the concurrency in Python, we have out-of-the-box concurrency support, like multiprocessing and threading. Or recently we have the concurrent.features module. Or the coming 3.4, it's going to have the tulip for a concurrent program. And also we have third-party libraries such as G-Event. And then Jega is, do you know this one? Jega. This is created by a Japanese developer called Mope. This is a kind of the Python 3 version of G-Event. And also we have a twisted and then eventlet. And then in order to do some inter-process communication, we have to have a kind of MEQ, like 0MEQ and a rabbit MEQ or something. In the case of Go, we have Go routine. It's a concurrent system for Go, like introduced in today's session by Benoit. This is really fascinating feature. For example, this program will call the waiter and hello in this order. So if you run this program, then it returns the value in the same order as written here. But if you write this Go keyword before the method before the function, then the Go launches the new Go routine, and then the waiter here is going to be called in another Go routine, and then process going to pass through that line, and then pass to hello function, and then result is going to be the different from the written order. So just writing Go before the function, you can launches the new Go routine. This is really easy to write, and then you don't have to think about the threading and then processing. So all that kind of stuff are done by a Go runtime system. So just write Go, and then the process scheduling, and then is done by Go runtime automatically. And then another feature for asynchronous program is the channel. Channel is the channel for inter-go-routine communication. So this is a quote from what Logback said. So don't communicate by sharing memory, but share memory by communication. So the image of channel is like this. So if you have a process A and a B, and it is run in different go routine each other, and if you would like to communicate to send the data from A to B, then you can use a channel like this. So the actual code is, so process A puts the data to the channel C, and then channel B can get the data, fetch the data from channel C. So it's really easy to write, isn't it? So this is another example. So pass the value to a channel, and then they close the channel, and then you can do a select like program more easily, and then make them concurrent for running. So this is a kind of an idiom for concurrent programming in Go, but compared with other languages, it's really easy to write. And then this is an optional introduction. So if you want to write some asynchronous concurrent prime number calculation, it is achieved by this kind of short implementation. And the topics here, the next topic, the standard packages and then useful standard tools. So this is one of the most comparable feature of Python and Go. In Python, I counted all these, and Python has lots of standard packages. It's like as said, battery included. But like Python, Go has lots of standard packages, such as crypto for encryption for security, and it also has encoding, such as dealing with CSV file or JSON, XML. And also it has image libraries, so we don't need to have third-party libraries for dealing with images, like in Python. So in the case of Python, we need to install the PIL for dealing with images, but not for Golang. Okay. Is this okay? You also have net HTTP. This is really useful packages. So if you want to write some HTTP server, you can write in maybe 5 lines. And also we have substandard packages. So this is not standard package. So if you these packages doesn't come with Go installation, but if you want to, you can install this from Go offshore repositories. And then this is also maintained by a Go core team, so the quality is ensured. So you have lots of cutting edge packages such as WebSocket here, and also Speedy version 3 is also supported. And then you have, so this is PyCon APAC, so maybe you are really concerning about character code. We support Japanese and then Korea, and simplified and then traditional Chinese. So if you want to write some country-specific code with Go, you can write with Go. And also, Go has lots of useful standard tools. In the case of Python, there is lots of tools for doing this. For example, for packaging, we have setup.py, but at the same time, as a third-party libraries, we have easy install and the pip. And for testing, there is a standard library unit test, but it is common to use a nose PyTest or test fixtures. And for linting, we have PyLint and PyPaid module. And then for documentation, we have PyDoc or even Sphinx. In the case of Go, it is provided by standard tools. So the Go command itself is a kind of army knife command. So if you give subcommand after Go, it deals with all required stuff for packaging and then testing, and then testing, and then linting, also the documentation. So it is really quite easy to get started. So I'm going to introduce some use cases. So for Go test, if you write some test named test blah 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 or benchmark blah 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 in the blah 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 underscore test.go, then if you hit the Go test, then this command automatically find all the functions, and it runs the auto test. And if it fails, it shows the cause of each fails, like usual unit test you are already using in Python. And then the Go format is really good to have, because the programmers like really bike shed discussion. Like, for example, I like indentation in 4 spaces or 2 spaces, or you should have a space between if and a bracket, or it should be the spaces before and after operators or something. But this kind of discussion is unnecessary. So we say that just run go format -w before your commit. Then all this kind of linting is supported by go format command. So you don't have to care about this kind of bike shed topics. And then also, if you want to automate the go format w command before commit, the automation script is also provided by the Go distribution. So please set this for in your repository. And then Go doc. And this command shows. This command is like the PyDoc or Java doc. So if you write a document in a comment, then this Go doc command generates the required document like this. So you don't have to have a separate document for specific libraries. It's really easy. And the next topic is external service. So the topics so far is about the features out of the box after the Go installation. But the topics after this is about the introduction of the external or more practical, more third-party use cases. So since the Go is created by mainly created by Go Quality, so Google App Engine also supports Go from App Engine 1.5.0. And then compared with the Python version or the Java version, the framework itself is really thin. So it is really easy to track all the source code. But at the same time, it has enough features for writing the web application. So this is really useful for speed required application, because as written here, the spin up time is really fast. So in the case of Python and Java, each instance have to launch the virtual machine for each languages. But in the time of that, the Go runtime launches Go binary itself. So before launching each language's virtual machine, the application itself starts. So this is really useful for speed required project. And then also, the important thing of Google Apple Engine Go is that the different from the Python version and Java version, the GA Go is maintained by the same team as the Go language itself. So both have the similar interfaces. So if you write some application for local machine, you can easily transfer that program to Google App Engine. This is really nice. So this is actual working example. So the directory structure, the minimum directory structure is right up. So you have to have up YAML and actual application code. The actual application up go here is like this. And the difference between the usual application and the Google App Engine application is that in the case of GAE, we don't have main function because the main function is in the Go runtime, GAE runtime. So in the case of GAE, instead of writing main, you have to write an init function. And then up YAML, you have to specify runtime Go and then version Go 1. And then with this, you can run the Go program on the top of GAE. And also, the .cloud also supports Go, but this is not the official support. So, like this is different from the GAE case. You can write a normal web application with net HTTP, and then just write a YAML file for specific this application, and then just deploy it to a .cloud. Then it gives the application. And in the case of Heroku, this is also unofficial support, but it is stably working on. So the directory structure is similar to other cases. And then if you use the third-party build pack, actually this is created by the developer from Heroku. So anyway, so just use this build pack and then push the source code to the Heroku, then it works. It's really easy. The CI services also support Go. So just specify the language Go and then script in YAML file. Then it gives a correct Go test result. And then other than Travis CI, the Drone.io also supports the Go. Interestingly, the Travis CI's Go support is kind of beta version, but Drone.io supports Go officially, not the beta. And then Python is beta supported in Drone.io. This is really interesting. And the same as the Travis CI, just write a build command in a web UI of Drone.io like this, and then it gives a result of a test of this source code. So this is web application support is kind of really good. And then I'm going to introduce some use cases. One of the most famous Go showcase is the group cache. Group cache is a memcache clone written in Go, but it also supports clustering system. So you can launch lots of servers at the same time, and then it automatically hashes the content each other. And this is open source at the OSCON 2013 in last month or 2 months ago. And then there is a presentation given by Brad Fitz. So if you are interested in this, please refer to that. But in short, the dl.google.com has written in C++ at first, but the Go team gradually replaced the components written in C++, and then finally completely replaced all the stuff, all the components written in C++ now. And then now the dl.google.com is written in Go program. And then also another big example is Vitess. So this is a MySQL load balancer. And if you access to YouTube, then the Vitess is behind it, and then it handles all the MySQL queries to YouTube. And the interesting is that the Vitess parses the SQL itself, and if there is some cache data on Vitess, then it returns the cached data. So it's not only supporting load balancing, but it's doing some kind of casting and also doing PG pool-like scheduling. This is a really interesting part. And if you're interested in Vitess, the presentation is available. This presentation is going to be published after this session. So if you are interested in, and then please access this link. But these two are done by Google. But outside of Google, there is another big example. Dozer by Heroku is one of the cutting-edge Go project. This is Paxos Go implementation. And then they are managing all the machine instance status using this Dozer. And then SoundCloud. Do you know SoundCloud? Yeah, SoundCloud is using Dozer as well. So this is a kind of mission critical part of a cluster system, but they're using Go as a production. And then recent news is that PayPal Beacon is using Go as well. And then Beacon is this kind of USB type gadget. But interesting is the Go is running on this this gadget. So this is the first, maybe this is first example of embedded Go. This is really interesting. I'd like to know the detail of this project, but I tried to find the back stories or the detailed information of this, but I couldn't find any. So if you find something, then please let me know. And the other showcases is Docker and Packer. Docker is an open source LXC engine by .cloud, and then Packer is a similar tool, but this is a multiple virtual machine image creator from a single configuration. And then this is written by the author of Vagrant. And another one is etcd. This is a Zookeeper clone in Go, but different from etcd. It's really easy to, it has easy to use API. So for example, if you want to test this etcd server, you can just hit the curl command, and then you can check the content inside clusters. The last one, this is the pointers for further information. So if you are interested in Go and if you like to get started for it, then please visit At12 Go because it has the complete tutorial for starting Go languages. So, and then this all stuff is done on the browser, so you don't have to install Go. So if you are interested in Go, then just visit the 12 Go. Then you can learn all the grammars. And then important thing is the example exercise here is not good enough. I mean, the example is exercise is really kind of complicated. So if you get stuck in the exercise, just skip it and then please go through all of them. And then after that, maybe you can start writing, some example project or tools. Then please refer to a standard package documentation. Maybe with this, you can write good tools. And also, there's a lot of useful documents on the golang.org official website. So there's a lot of stuff like a best practice of Go and effective Go, and how to getting started, like how to create a workspace directory or something. So all things are on the official website. So if you go through all documents on Go official page, then maybe you can be the intermediate or advanced programmer of Go. The installation is really easy. There is a pre-built binaries on the web page, the official page. So just download the binaries and then just install it. There is MSI for Windows users, so it is as well. So it's really easy to install. So you have to have a workspace for each project. So just create a directory and make a package and a source directory inside it. Then set the environment variable. That's it. And for further information or more latest information, please join the mailing list, Golang Nuts. And also we have Google Plus community, Go Plus. And Reddit is one of the most active place to have a discussion. So if you check these three, then you can catch up all the latest information related to Go. And that's it. If you have any questions, please ask. Thank you.
Do we have any questions from the audience?
Hi. You showed earlier an import statement that uses a URL, and it resolves at build time, or when you say go get. Do you guys use that within Google as like URLs to fetch? Because it seems, I understand like you could probably say like I want specifically this version and it would get it from a central repository, but in general it seems like, you know, kind of ripe for abuse where you don't know, you can't rebuild what you had built originally.
Okay. Unfortunately, I can tell you that whether we are using the external repository, but what I can tell you is that the point is under discussion on the Go developer team, because as of now, the Go doesn't have the package, the version management system. So it always fetches the latest version of a specific library. So it may, it may be a cause of the build failure. So it's under discussion, and then many people are trying to create the way to specify the specific version of a specific library. So if you come up with any good solution, then please give us the example. Yeah.
We built something like that, very simple.
Thank you.
Okay. Okay, so we go there first. Then we go next to you.
Okay, I have two questions.
Yeah.
The first thing is, recently in making concurrency model more efficient, recently the idea of transactional memory is becoming more popular. So the Go, if Go doesn't support shared memory, how would it be integrated into the language?
So you mean the kind of support for transaction or something?
Yeah, transaction memory. It's a way of removing locks when you have to synchronize that. And recently it's hardware supported.
So usually we use channel, but there is the sync packages as well. So and then. Yeah.
So there's no problem. Okay. The second question is, do you have any tips on web searching Go? If you just look for Go, and you get nothing.
So the bad thing of Go is that really bad. It has really bad readability. So instead of just searching with the word Go, just use Golang. Then you can find relevant documents.
In your slide, you show you use Python for everything and you use Go for everything. And which area you will use continue to use Python, and which area will you feel replace Python with Go?
In my case, I write kind of mock or kind of testing use cases in Python, like for example, dumping my idea into code using Python. But if you want to make it more maintainable, or if it is going to be used by others, then I write in Go, because once you compile it, then you can just give a binary to the others, and then others do not have to take care of the setting up an environment to run it. So that is how I distinguish the case.
Do we have any more questions? Or are you guys just ready for a party tonight? Right. Okay. Questions? Okay, so thank you. Let's give a round of applause for the great presentation on Go and also Python.
Thank you.
Okay, so before we close and head to the party, there's some announcement that I would like to make from the committee. Okay, first, there's a change in tomorrow's program. One is